Okay, well, for today's project, an uncle of ours has a little bit of a machine he's building. What he's wanting to do is build a concrete cutter using a concrete blade, typical however many inch blade it is. And so we picked up the blade, but he has some pillow block bearings, and we have a piece of shafting here. What he wants to do is he wants to put the pulley with a keyway on the one end, except he has to space it off from a couple pillow block bearings, using a spacer on the one side, spacer on the other side to the other pillow block bearing, and then we need to make a couple 4-inch slightly concave washers to go on this end to sandwich the blade. Then on this end, outside of that, I have to cut a left-hand thread because of the direction this thing's turning. He doesn't want the nut coming loose on him. So this is what I got for a diagram. He drew it right on the back side of the package for the blade, which is nice because I have the blade to test with. So we have the plate that everything's going to be mounted to is 13 1/8 wide, so 13 by 125, and then he wants the edge of the pillow block actual bearing portion, the turning portion, inner race, will be 3/4 of an inch from the end. So these spacers are 1 inch to the shoulder, so we'll be turning those down a bit so that we can be a 1/4 inch offset from either side of the plate with the pulley here, with the concave washers sandwiching the blade, and a 1/4 inch off the edge with the pulley edge. So to work with that for the actual measurements, I sat down and did all the subtractions and additions, and it turns out that this shaft we're going to have to cut off to 17 1/4 long, and then this bushing here, spacer, it's going to be used as a spacer, that will have to have this shoulder completely taken off. He was wanting that for both of them. However, one thing I think I'm going to do for him, this is about 1 5/8 as far as the outer diameter, and this guy here is just a hair over 1.5 inches. So it's really, really close. What I think I'm going to do is I'm going to take this and actually turn it down so that it's about 1.5 inches, so it slides into the back side of that pulley. What that'll do is I'll definitely maintain the spacing, but it also provides a little bit more support on the back side of this pulley, because as this taper lock is pulled in, it's not going all the way through that pulley, so this gives it a little bit more rigidity. So yeah, on this shaft here, the one end over here I have to cut down and make a thread on. This end up here, I'm going to have to cut a keyway in. As far as the plates, or the washers, he's given me material to work with. So a couple rough cut plates like this, 3/8 inch steel, just typical, scrap stuff you must have had sitting outside somewhere. We'll make it look a lot nicer before we're done. But yeah, they have to be 4 inches outside diameter and 1 inch inside diameter hole. What I'm going to do is I'm going to use a little trick like I used when I made some backing plates for my dad's mini lathe. As far as making a nut, I know it's a little overkill, but it's what I have in stock. I have some 1 3/4 hex bar, and so I'll just face off the end. I'll probably cut a chunk off, maybe about 3/4 of an inch long, face both ends, and then drill it, use a single point tool, and thread it from the inside using a single point tool on the lathe, because I have no left hand thread taps that large. All of my stuff's right hand. So yeah, that's what's up for it this time, and let's get started. We'll start cutting that bar off and finishing laying out these plates. Okay, so we got all our parts. The 2 sleeves that they provided me, the pulley, our shaft cut off to just a little over 17 1/4. That gives me a little bit of room to face on both ends, to face and put a center drill mark on each end. And our 2 plates. Like I say, I just used the bandsaw, cut the rough square out, and then used the bandsaw in the vertical position to take the corners off. I also took a 1 inch chunk of that 1 3/4 inch hex bar, and that will become our left hand thread nut when we're done. So first thing I need to do is, what I think I'm going to do is I'm going to do the plates first, or the very, very lightly tapered washers. What I'm going to do is, I still have my center mark here. I'll be drilling it out to a 13/32 hole. So that gives me the right tap drill size, well, close enough, for a 12 millimeter by 1.5 millimeter pitch thread. Because I made this, or well, I modified this bolt a while back. Modified this bolt a while back to put a center in the end of it, and then that way I can use the 3-jaw on the one end, the live center on the other, and when this plate is threaded on, I can use that as my arbor to do whatever I want to the front. So what I think I'm going to do to start with is drill and tap them, mount each one on one side, face that side close to the very center, because again, this is all going to be gone. It's going to be cut out to 1 inch. Face it to that point and clean it up, and that'll be the back side. I can then flip it around and then cut the outside edges, cut the outside edges off and make it a circle. Do that to both. Then I can just use the outside jaws on the lathe and cut my taper, face this side, cut the taper, and then drill, or well, finish drilling out and then boring to 1 inch and probably a couple thou clearance to get over the shaft, the center hole, and the washers. So we'll do the washers first. So, make sure you're in the right spot. There we go. Again, this isn't the most critical of tolerances. If I were having to be more precise, I would have just done it in the mill. But the mill is still clean. I didn't want to have to clean it again just for doing a couple holes. I don't know, it just seems like the older I get and the longer I'm a mechanic, the less feeling I have left in my fingers, and I keep dropping things. I see John doing that too, and I wonder if it's just normal part of the trade, because I mean, I have less feeling in my fingers than I know I should. Lose the feedback pressure and feedback and heat. I mean, I can sometimes pull stuff out of the oven without actually eating oven mitts. Believe me, it's not that I'm bragging about it, it actually kind of concerns me. And I don't have that much feeling. There we are. Alrighty. The concept of tapping is certainly not new to most people on YouTube who are doing machining stuff, but just figured to see what I'm doing here. Trick is getting it straight to start. You get it straight to start, you're laughing. Like I say, this is only a temporary hole anyway, so just has to have threads to hold the bolt that I'm using as an arbor of sorts. Again, I don't really do things in a really complex manner here. Just simple building parts for friends and family. There we go. worked just nicely as an arbor. Like I say, the second plate's doing the same thing, so I'm not going to bother with filming the second one. I'll just tap it and make sure the bolt goes into it as well. And next thing you know, we'll be over on the lathe and we'll start cutting these corners off, knocking the corners off, and cleaning up the one face. Okay, so got the plate mounted up on the bolt, got the hole threaded into the 3-jaw, or mounted in the 3-jaw. I've just taken one pass already just to sort of make sure I'm reasonably close. A couple passes here with the bit. It is an interrupted cut, so unfortunately there's going to be a bit of vibration on it. But here goes. I'll show you how it works. I'm only doing about a 10th thou depth of cut. On a bigger machine I could probably do a heavier depth of cut, but again, this isn't that big of a machine, so you sort of work within your limits. And yes, I know there's a little bit of run out in the actual blade itself. I can see it from where I'm standing. I don't know if you can see it on the camera. There's a little bit, but that just has to do with the fact that my threads weren't perfectly square. I couldn't necessarily start the threads without adjusting the table on that drill press. And unfortunately, that little drill press has those little drill presses. The table is not that solid on it, so I went up having to use extra bracing, and it's a real pain to move it. It's 3/8 plate for the washer, but realistically speaking, he was only looking for 1/4-inch washers to begin with, so it comes out just a little under 3/8, you know, like 335, 340, somewhere in that neighborhood. Then it's not the end of the world. He was originally thinking 1/4-inch washers, but he didn't have any quarters, so that's why he provided me with 3/8 material. I think that's circular now. Close enough. A little bit of radius there from the original edge of the material, but that's okay. That's going to get cleaned up anyway and made into a radius as well. And move our tool. Again, we don't have to get all the way to the center, just have to get close, which is good because this tool is actually an industrial tool bit holder, and it doesn't, sometimes I find it has a little trouble clearing to the live center. Skim there. Got a little chatter there. You have to try a different tool angle. That's cutting a little better. So, chamfer tool in there. Get that back edge. There you go. So once I face that front portion, it will be parallel within a few thou of the back surface back here. And so what I'm going to do right now is I'm going to even just start by setting my compound rest to almost square, but just with a little bit of taper to it, just to allow for dishing the center. All that was for was just to get a rough skim. Yeah, I'll take one more. That'll work. Now, you can see that's the very center, the farthest forward that it's the farthest forward that the compound slide will move. That's the end of its travel. So, relation of shaft. The end of our travel there, so bring it back a bit. As you can see, it is cutting a chip up until we get out to about there. No, the chips aren't great, but that will be acceptable, because it goes up to about the outside 3/16 or so. Outside 3/16 hasn't been touched, and that'll create a nice pressure area. So yeah, I like it. Now, you have to be very, very careful. And break the edge. There we go. Break the edge of that disc with the, I could use the sharp point to the CNMG tool. There we go. Now I just need to drill out that hole in the center. Take it out with a, I have a 1-inch drill bit. I'm just going to drill it out with a 1-inch drill bit, and then go from there. Took a little bit to find its center, because of the fact that I have a suspicion it's probably because it's got a thread in the center of that hole. If it cuts the hole 10 thou, 5 thou, whatever, oversize, because it's just a washer. That's all it is. One washer finished. Just have to deburr it. We're off to the races. Light touch. There we go. I use this tool for all sorts of stuff. I really like the CNMG tool holders. So now, there we go. There we go. Slight dish toward the center, chamfer toward the center. The outside 1/8 inch 3/16 or so is still parallel to the back. Take that burr off. You're good to go. I'm going to try turning down the one for the pulley first, because that way if I mess it up, then I can just completely clean it off, and that gives me a second chance. Change my angle of my tool here. Alright. I do need to shorten it a little bit though, just so there is the possibility as that tapered bushing goes in, the tapered collar, I need to shorten this because there may be possibility of this little shoulder interfering with the drive bushing, the key drive bushing that is tapered where it goes in. That tapered drive bushing has to push further and further inside the bore of that pulley, and I don't want it to interfere. So we're down to, yeah, about 1/4 inch. That'll be enough. Change our angle on our tool so that you can come up to that shoulder. And, alright, here we go. Off. Here's the dials for this one. That's 40 thou. The inside of that hole is 1 inch 546 thou or so. 1 inch 585. Inch 585, 1 inch 546, 47. So we need to take another 40 thou off. Again, I'm going off the dials, which on this machine are close. A little bit more. Thou on the way out. There we go. That's it right there. Get that out, put the chamfer tool on. There we are. Yeah, that's nice. We'll roll with that. So the other one will be much easier. I just have to face it down till it's only 1 inch tall. Pretty sure that brings it out to 1 inch. So what I need to do, I'm just going to pop it out, take a measure. Ha! 1 inch 2 thou, and she's a little bit warm to hold, so I bet you it's going to cool down to within a half a thou. Bingo! I'll just have to manually deburr those to the inside of the bore, because it's kind of hard to do that with the keyway otherwise. And yeah, alright, so 3 of the 5 parts that Uncle Tim needs for his concrete cutter are done.